So, my name is Boris Larin. I'm working in a global research and analysis team at Kaspersky. And at work, I find their days exploited in the wild. So last year, we were extremely honored to speak at the first ever BlueHat Shanghai. And we presented our research, which was a review of the latest Windows OS kernel exploits found in the wild. And in that presentation, we shared information about the most interesting vulnerabilities. And we also gave a sneak peek into exploitation framework that was used among many 0 days. So today, I'm really happy to share with you more information about this exploitation framework. And I will try to explain how it's possible to provide 0 days as a service with all these antivirus vendors looking for them. And also, I will share with you more information about 0 days that we found in 2019. So here's a brief recap for this presentation at BlueHat Shanghai. So in 2018, in total, we found 4 0 days. There was an attack on Microsoft Office through the Internet Explorer. Then we found a first known case, which was targeting Win32k in latest build of Windows 10 at the moment of discovery, which was Redstone 4, after all these new mitigations were implemented. And then we found one more 32k vulnerability, but it was not that much interesting because it was targeting only older builds, but a very sophisticated framework was discovered. And then we found one more relational privilege, and this one is very interesting because it was a bug in NTS kernel, and it allowed you to escape sandboxes of web browsers, and also it revealed some novel exploitation techniques. So the last 2 0 days, they were part of the same exploitation framework. And it's not possible to talk about this exploitation framework without talking about 0 days market. So 0 days exploits, right now it's a multi-billion-dollar industry. And there are a few companies who work in this area, and some of them have a lot of publicity, and well, some others are not. And we observe a rapid growth of number of entities who develop and sell exploits in volumes. And each of these companies, they have different models, and some of them are picky to choose customers, and there is a possibility that some others are not. And they do a greater harm, and like 0 days used in the wild, they are too risky to be silent about if you encounter one of them. So when such products of such companies, when they are used in the wild, it's just a matter of time until we or our industry partners stumble into one of them. So we encountered multiple attacks that were using a unique exploitation framework. And those attacks, they were conducted by several threat actors. And this exploitation framework, it seemingly contained an armory of different exploits. And the functionality of this framework, it also included an antivirus evasion. It was choosing appropriate exploits reliably, and it also contained a very sophisticated direct kernel object manipulation. So I'm actually often asked, like, how do you even find 0 days? Like, don't they, like, before execution of any exploits, don't they check, like, antivirus is installed? And I think, like, it will be perfect if this was the case, because it will mean that if you install antivirus, you will be not attacked by 0 day. If attacker not cares about burning 0 day, of course. And also, right now, all personal computers, they come with antivirus by default. It's actually a Windows Defender. But imagine a product which is basically a collection of 0 days. And there are 2 sides of a story. We have a manufacturer of such product and the customers. And for manufacturer, it makes sense to protect 0 days because it's a valuable asset. It gets sold to new and potentially and other customers. And for customer, like success of operation, this is what matters the most. And depending on license model, customer might not even cares about burning 0 day. So one customer burns 0 day before others use it. So like for manufacturer, it's a loss. So it seems like protection of 0 days, it's a problem for manufacturer if exploits get sold non-exclusive. So in this framework, anti-IV evasion, it starts right from the moment when shell code is executed as a part of full chain. And all API functions, they are executed using specially built trampolines. So framework, it searches for special gadgets that are present in system libraries that are already present in a process, and builds like fake stack to use this fake stack to execute all API functions, and it's kind of similar to return or return programming, but that's done purely for antivirus evasion. And shellcode, it's used to execute embedded portable executable module, and this module is a central part of framework. It contains logic to execute exploits and backdoor, and in this module, all API functions, they are executed using the same trampoline technique as in shellcode. But this embedded module, it also contains an additional antivirus evasion logic. But implementation is quite strange. Depending on a version of Windows, it will check for special libraries that are already present in the process. And in case if any of such libraries are present, then it will terminate execution before executing any of exploits. So actually, we are quite lucky because we were able to find multiple builds of this framework. Like here, what happens in the older builds, like in case of Windows 10, it will check that emmet is present on the system. And in all other cases, it will check for Bitdefender. And in new builds, they also added check for Malwarebytes and one more unknown library. I don't know which one it is because they also started to compare the names of the function of the libraries using CRC checksum. And actually, this is check that happens before execution of additional exploits, but there are also some additional checks that happens right after it. So, I have a feeling that like in the next versions of this framework, developers will try to check for one more antivirus vendor. And like remote code execution exploits, they may be triggered more than once. And I like how much attention in this framework is paid into ensuring the best possible reliability. Because like in case of elevation of privilege exploitation, execution of multiple instances will lead to blue screen of death. So a proper mutual exclusion is required, but use of mutex API function, it may arouse a suspicion because it will be detected by security solutions. So this framework, it uses quite interesting technique. So basically, it acquires log to the heap and walks over all the blocks located on the heap. And it checks their size and its content. And in case of such special block is already located on the heap, it will mean that this exploitation framework is already running, and it will terminate execution. But in case if it's not present, then it will just allocate it and will fill it with data. So it will have mutex. And the framework module, it may come with multiple exploits, embedded or received remotely. And each elevation of privilege exploit, it provides a special interface. And like each exploit, they perform a number of checks to check if target is supported. And what framework tries to do, it just executes all of them in a loop, and it's performed until one of them succeeds. So quite likely, but each exploit that we found, it contained a debug information that revealed codename of exploit. So developers, they granted each elevation of privilege exploit with the name of the girl. And in total, we have found 4 exploits. We have found Alice, we have found Tristan, Dana, and Jasmine. And I really felt like there is a possibility for naming pattern, because you see that maximum number of exploits, it's equal to 10. And G, in English alphabet, it has an index 10. So, and Jasmine, it also looks like the most modern exploit. And in the same time, Alice looks like the oldest. So we looked really hard, but couldn't find any more exploits from this framework. But we shared this information with our partner, and using information that we provided, our partner was able to find more 0 days, and in the end, vulnerabilities were fixed. So we believe that the main purpose of this framework is full chain attacks. We succeeded in analysis of privilege escalations and backdoor, but our knowledge about this framework is quite limited. But we know that this framework was observed to be used as payload for Flash 0 Day CVE 2018-5002. So let's talk about our newest findings. And in 2019, we have found 4.0 days as well. So there were 3 Win32K elevational privileges and 1 remote code execution in Google Chrome. So here's the first of our findings. It's a race condition in Win32K driver. And actually, it was abused in Dana elevational privilege exploit. And it's the last 0 days that was used by this framework and that we found in the wild. So exploit, it supported the following versions of operation system. So Win32K driver, it contains code for direct composition API. And it's a relatively new part of functionality for Win32K. It was introduced only in Windows 8. And basically what it allows you to do, you can use it to combine and animate different elements. You can make bitmap composition using with transforms, effects, and animations. And you can use it to combine bitmaps of different sources like GDI, DirectX. And you can do that using tree-like structure, similar to visual tree in XML. And it's a relatively new part of functionality, but it already was exploited before. So if you want to take a close look, I recommend you to look for syscalls with the following prefix, NTD composition. And this is the first. Let's find out what vulnerability is. And here's the first syscall, NTD composition discard frame. So basically what it does is just what like the name says. It can be used to free some frame. And then we also have another syscall, NTD composition destroy connection. And it does a lot of things, but it also frees all the frames. So execution of NTD composition discard frame syscall and NTD composition destroy connection syscall at the same time, it can lead to use after freeze scenario. Because discard all composition frames, it may be executed at the time when NTD composition discard frame is looking for a frame to release or has already found it. So exploit, it uses 2 distinct exploitation techniques. And they are abuse of GDI palettes and abuse of windows. And they are used for the following versions of Windows. So here's the first technique, abuse of GDI palettes. So what exploit does, it grooms heap using palettes, and their addresses are leaked using GDI shared handle table technique. Then it keeps a couple of palettes allocated next to each other, and on the next step, it uses vulnerability to free palette number 1, and reclaim memory, and overwrite the entries field of palette structure. And then set palette entries API functions on palette number 1 can be used to overwrite the first caller field of palette number 2. So we have arbitrary memory read and write using set palette entries and get palette entries. And here's the second technique. So exploit, it grooms heap using NT user create input context and create window X. And then exploit leaks kernel addresses of Windows, which are basically in kernel that are present as tag windy structure. And they are addresses from kernel leaked using G-shared info technique, which is also well known. And then it uses vulnerability to free window and reclaim memory and overwrite a star name field of tag windy structure. So in the end, it has arbitrary memory read and write using internal get window text and int user dev set text API functions. And well, in this framework, each elevational privilege exploit, it provides interface for direct kernel object manipulation. And all exploits, they are written in C++ with strong use of object-oriented programming. So we have a class with the following functions that can be used after exploitation. And there is also a special functionality that can be used to get kernel shellcode executed. So let's talk about post-exploitation. And like almost every elevational privilege exploit that we find in the wild, it uses only data-only exploitation. And the most common scenario exploit works a process structure and seals system token. That's what we see all the time. But this exploitation framework, it uses direct kernel object manipulation to get kernel code execution. And this is a sophisticated functionality that is not commonly observed. So in this case, it's really worth taking a closer look on actual implementation and kernel shellcode. And we are also quite lucky to see evolution of this functionality. So here's the implementation observed among earlier variants. And at first step, it puts shellcode into some kernel object whose address can be leaked. It can be done using create accelerated table API function with a gshared info technique. And on another step, well, considering that we already have access to your process structure, it duplicates thread to current thread and then parses your process object table structure to get address of kernel thread. Then it gets address of kernel thread scheduler RPC and verifies that it's a kernel RPC object using type from key objects, enumeration, and address of kernel thread. And then address of KPC normal routine is stored for later use. And on third step, exploitation framework, it resolves base addresses of page table entries and page directory entries. In Windows 10 build 10586 and below, these entries, they are based on fixed addresses. And in other cases, they base addresses, they can be resolved dynamically, heuristically, if you have access to kernel image. And then those entries, they can be accessed with the use of this calculation for any virtual address. And in case if you are wondering how it's used, modification of an X bit in this page table entry, it will mark this page as executable. So on the final step, normal routine pointer gets a written visual code address. And right now, page visual code, it's already made executable. So suspending current thread will make visual code executed. And then normal routine original values get restored, and current thread is resumed. And kernel shellcode, it actually borrows a lot from open source Blackbone project. And code is very similar to Blackbone driver. Well, what it does, it just injects some whatever library you provide to chosen system process. In all cases that I have found, it was SVC host. And injection, it's achieved exactly like in Blackbone driver. So we have a reflective portable executable loading from the kernel, and then user code is executed using special trampolines and creation of worker thread. And you know, like Blackbone driver, it's well, source code of it, it's very well known to be used in malware. And probably the authors of this framework, they were afraid of this extra publicity, and they decided to re-implement this part. So this is technique that was observed in new variants. So at first step, it creates a dummy thread, and this dummy thread, it has only one API function call, signal object and wait. So this thread is created and executed, and then the process object table gets parsed to find the address of kernel thread. And on the next step, exploitation framework, it reads the values of thread stack base and thread stack limits from this kernel thread. So what it does next, it just tries to parse and perform back search for all values that are present on stack and checks that they belong to kernel text image. And bytes at correct return address, they should have the following signature. So when the right address is found, this framework, it builds a rope chain, and it gets written to the stack. And then event to this thread gets fired, and rope chain gets executed. So in this case, kernel shellcode was not even needed, because this technique, it lets to execute any kernel functions using this rope from user level. And that's what we have in the end. Exploitation framework, it uses return programming to execute all functions from the kernel, and it's used to get code injection to chosen system process. And summing up, DCOM, it lets you to use many more interesting techniques other than just stealing system token. And advanced threat actors, they are already using them. Like living in the kernel land, it has a number of advantages because it's the same level where antivirus products live. And not that long ago, Microsoft, they have implemented a system guard runtime attestation framework, which is aka Octagon. And what it does, it checks integrity for the system to check that if it was compromised. And sophisticated actors, they're going to be very interested in trying to bypass it. So I believe in the future we are going to see more malicious uses of direct kernel object manipulation. And besides Dana exploit, in 2019 we have found 2 more elevation of privilege exploits. And both were vulnerabilities in Win32k driver. And quite interesting that root case in both cases was quite similar. And all of them, they were exploited using some public known technique, and they only supported all the builds of Windows 7. So I will be not going into details about them. And actually, the vast majority of exploits that we found in the world, they target only older builds of Windows. So Windows 10 is commonly supported, but only older builds. So exploits that we found last year, they are unique, I think, because they exploited the latest builds. So if you're really interested, I recommend you to check the slides for BlueHat Shanghai. And it seems obvious that finding vulnerabilities is much more easy than developing novel techniques to exploit them. And the majority of zero-days exploits that we found recently, they are kernel exploits. But that's not the only thing that we are working on. We also look for remote code execution exploits, but there are some complications. Well, our technologies, they aimed at detection and prevention of exploitation. And exploit detection, it's not the same thing as zero-day finding, because for zero-day finding, additional analysis is always required. And quite often there is simply no information that is needed to perform analysis. Because like at first signs of exploitation for web browsers, they already might be nothing in memory. Like all scripts, they were just in time compiled and freed from the memory. There are no interfaces available to kindly ask a browser to give these scripts. But we work on such problems, and zero days gets found. So Google Chrome used after free in audio. Its originally exploit supported only Google Chrome versions 76 and 77. They were not the latest at the moment of discovery, and exploit supported only them. But we were able to fix exploit and prove that it's a zero-day. And we call those attacks Operation Wizardopium. There are no definitive things with any threat actors, but there are some weak code similarities with largest group, but we believe that it could be a false alarm. And because the profile of attack is more similar to dark hotel attacks found by Google. So this exploit, it was distributed with watering hole style injection on Korean language news portal. And there were multiple redirects and layers of obfuscation and encryption. Like actual exploit, it was split into multiple chunks that were RC4 encrypted, and then they were joined and decrypted. And key for actual payload also was appended to some GIF image that was also retrieved. So Maddie Stone, she already talked with you about vulnerability and its root case. So I will focus on exploitation. So as you know, vulnerability, it's actually a risk condition that results in use after free. And how it's exploited? Well, exploit, it triggers use after free to leak pointer of audio flow array, and it defeats SLR and makes it possible to retrieve some very useful pointers. And then the freed object, the memory, it gets sprayed with attempts to reuse this freed buffer. And control over audio float array, it lets to achieve arbitrary read and write. So it's quite interesting that exploit, it comes with some huge WebAssembly object that contains dummy logic, basically just like an op instructions. But V8 engine, it compiles this WebAssembly bytecode into native code and puts it into a readable, writable, and executable section. So what exploit does, it just rewrites this section with a shellcode. And then exploit it uses file reader technique to trigger execution of this shellcode. It's a technique that is very similar to the one that was used in Chrome 72 file reader use after free that was released to the public. So unfortunately, like, there are just not enough time to talk about each and every zero day that was found in 2019, because there were a lot of them. Like, the number is quite scary for me. But I hope that you enjoyed my presentation about 0 days that we found. So, I want to say a huge thank you to Microsoft and Google for handling our findings very fast. I mean, it was just a matter of days when we got these vulnerabilities fixed and deployed to users. And like sharing detailed information about vulnerabilities, it's very important. And I want to say thank you to Microsoft Active Protection Program team. Details about our findings, they were shared through this program, including proof of concepts that triggers these vulnerabilities, and similar vulnerabilities they were found, and sharing insights about 0 day, about threat actors, it also brings great results, because more in the world 0 days gets found. And right now, making 0 days, it's hard, but not hard enough. Really huge money involved in this business. And I predict that exploits, they will act more stealthy on platforms with good visibility. We are going to see a better antivirus evasion checks, and I guess we will see novel uses of direct kernel object manipulation to bypass system guard runtime attestation. So that's all. Thank you.